Welcome to today's online session. I am Dr. Shubha, working as Assistant Professor in the Department of Artificial Intelligence and Data Science at SA Engineering College. Today I am going to explain the most important and powerful machine learning algorithm, the Navy Bayes. This lecture is specially designed for gate coaching as well as who wants to get clear explanation about the Navy Bayes algorithm. So this lesson I am going to cover what is the Navy Bayes algorithm, what are the mathematics behind it, how the algorithm is work in a step-by-step manner, and I will explore the different type of Navy Bayes algorithms, and end of the sessions I have some sample gate questions. Let's see the basics definition of Navy Bayes and the common application. The Navy Bayes classifier is a supervised machine learning algorithm, which means the datasets contain both input and the output label. The Navy Bayes algorithm is majorly used for the classification task. It also known as probabilistic classifier because it uses the Bayes theorem and it uses the principles of a probability to make a decisions or to perform the classification task. Let me explain with a simple example. Imagine you are a doctor. You are going to diagnose the disease. The patient comes with symptoms like fever, body pain and cough. You know the past experience. So based on the experience, you know the fever is common in flu, the body pain is common in flu, and the second case cough is common in flu. So based on these symptoms as evidence, you can decide whether the patient is having the disease like flu or not. So this is how exactly the Navy Bayes classifier works. Instead of saying the output class as yes or no, it calculates the probability of each class, then it select the class which have the higher probability. So that's why it is called as a probability classifier, because it uses the evidence and the probability to calculate or to classify the final outcome of the class. Let's say the common applications of the Navy Bayes include the spam filtering, sentiment analysis and document classifications. In spam filtering, the Navy Bayes algorithm classify the incoming mail into the spam or not spam. When considering the sentiment analysis, the Navy Bayes algorithm deducting whether the review is a positive or negative. This case I am taking as a binary classification. Suppose if you want a multi classifications, then it's classified into the review in positive, negative or the neutral. The last one is a document classification. Actually here the Navy Bayes algorithm categorize the news article into the topics like the articles comes to the sports or politics or the technology. So these are the common applications of the Navy Bayes I have listed here. I explain the Navy Bayes algorithm follow the Bayes theorem. So first we have to understand what is the Bayes theorem. Actually the Bayes theorem help in updating the probability of an event A with a new evidence B is observed. So it is useful when the probability of the evidence depends directly on the other event. It allows us to refine our beliefs that based on your evidence. For example, if a person tests positive for the disease, after seeing the result, the Navy Bayes algorithm helps to calculate the probability that they actually have it based on the how reliable that test is. This is how the Navy Bayes algorithm helps to update the probability of the occurring event A when new evidence B is observed. So this is the mathematical representation of the Bayes theorem. We can see the probability of event A given B. The probability of event A given B is calculated by the probability of event B given A overall with the probability of A and probability B. So where the probability of A given B is called as a posterior probability. It means the probability of event A is happening given that the event B has already occurred. Then the probability of B given A is called as a likelihood, which means if A is true, how likely is it that is it that event, this is event absorb B. Then the next thing, the probability of A is called as a prior probability. It is our initial belief about A before seeing any evidence. And the last term, there is a probability of B. It is called as a evidence or the marginal probability. It is the probability for the event when observing B in general. That is, we already known to this. These are the common terminology for the Bayes theorem. It is mainly used for the Bayes algorithm for classifying the new data, or from the training data it uses the Bayes algorithm to classify the input data into their preferred classes. Let me see the Bayes algorithm. This is the mathematical part of this Bayes algorithm. It majorly uses the Bayes theorem. Suppose if you take any data set, I already explained, this comes under the supervised algorithm. So the data sets contain both input features and the output features. This is the real-time data sets. You can see the input features are outlook, temperatures, humidity and windy. The output, that is the target class here. So the previous calculations, I have taken a data set. That data set should contain both input features and the output features. In that case, I am having the 4 input features. So I am representing x1, x2 and so on xn, and then 1 output classes, that is y. For finding the unseen data sets, the Bayes algorithm used to calculate the posterior probability by using the Bayes theorem. That's what I have written here. The probability of y given x1, x2 and so on xn. Here y is a event A, then the input feature is event B. So we are applying the Bayes theorem. The formula is rewritten as probability of y into probability of x1, x2 and so on xn given y divided by probability of x1, x2, xn. In general, the Bayes assume all the features are independent each other. So we can write this part as a probability of xi given y, because each input is independent, which means we can write the probability of x1 given y into probability of x2 given y and so on, probability of xn given y. In the mathematical formula, we can rewrite this into the terms of pi. That is, the probability of the output class, that is the posterior probability P of y given x1, x2 and so on xn is equal to probability of y pi into P of xi given y. The pi ranges, I value ranges from 1 to n, because for the each input or any data set we have a n number of input features. That's what we mentioned, I ranges from 1 to n. That's divided by probability of the input features. Since the denominator part is constant for the given input, because if you take a data set, it have a n number of features. For all the rows, this value should be the constant. So I can say the output class of the probability, which means the probability of y given x1, x2 and so on xn, is directly proportional to the P of y and this calculation part. So the final output, I can say the final outcome is y cap. The y cap is determined by the argmax of the product of these calculations, which means the argmax is always select the class which is having the highest probability of the class. For example, the next slide we have a output class, right? In this we are having a 2 category, present class. The 2 categories are present and not present, right? Suppose the probability of the present class is 0.7. The probability of the not present class is 0.3. The Bayes algorithm uses the argmax, which always choose the class which have the highest probability. This is for the not play, this is for the play class. So this algorithm is always select the class which have the highest probability. So the previous example, I can say the final output as a first class. That is, we can the player may play on the particular day. So here I taken the example data sets to understand how Navy Base is performing the classification task. Actually, this data set is commonly referred to the play tennis data sets. This contain 14 instances. Each instance represents the particular day weather conditions. You can see this data sets contain the input feature as the outlook, temperatures, humidity and windy, and one target class, that is the class. It contains two subcategories, whether the player is played on that particular day, whether the player is played on that particular day or not. So this data set, again, if you are going for the first input feature outlook, it has three features, that sunny, overcast, rainy. Likewise, temperatures which have hot, mild and cool. The humidity features have the two subcategory, high or normal. The windy has two features category, like true or false. So this is the common data sets. It have the n number of features. When new data set is entered or when new data is encountered, you are going to calculate or predict the output class of the unseen data by using the Navy Bayes algorithm. So in the next slide, you can see how does the Navy Bayes algorithm work for the unseen data. For calculating that or for predicting that unseen input data, we have to follow the steps here. The first step is we have to convert the data set into the frequency table. Here count how many number of S, which means the played class, and not played cases exist. That is called as a frequency table. After that, we have to create a likelihood table by finding the probability for the each attribute's value. Then we have to apply Navy Bayes equations to calculate the posterior probability for the both classes, whether the player is played or not played. Then classify the outcome by based on the argmax. As I explained earlier, the argmax is going to pick up the class which has the highest probability. So you can see here, this is our input data set. The first step is you are going to calculate the frequency table. So in the frequency table, we have to count the number of instances for the each attribute value. First I am taking the output class, that is the target class, which has two category, that is played or not played. So here the total number of instances, what is the total number of instances? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So total number of instances is 14. We have to count the number of instances for the present class. How many present class is there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of instances for the present class is 9. Then how many number of instances are present in the not present class? We can directly calculate. Total number is 14. 14 minus 9, that is 5. So we can check the not class is 1, 2, 3, 4, 5. So this is how we have to calculate the frequency table for each attributes. And the next one, we have to calculate the likelihood, that is the probability table for each attribute. Here we already calculated the present class number of instances 9. So the probability of the present class, we can write probability of P is equal to 9 by 14. This is 14 is the total number of instances and 9 is the number of instances present in the S class alone. Then probability of no classes, same way we can calculate it. This is 5 by 14. Now moving on to the next input features outlook. In the outlook we have three subcategory. In the outlook it has sunny, overcast and rain. So here we have to calculate the probability for the each instance. Let's say probability of sunny given P, that is in the present class we have to calculate the number of instances in sunny. So let's take sunny. So For the sunny class, we have to calculate number of instances 1, 2, 3, 4, 5. So in the sunny class, again we have to check the presence class. So what are the present class? This is no, this is no. So this one is no. For this case, it's present. For this case, it presents. So the probability of sunny given the present class is 1, 2. So it is written as 2 by 9 because 9 is total number of class presence in the present class. So we can written as a 2 by 9. So likewise we have to calculate the probability for the other features. So probability of overcast given the present class is 4 by 9. Can you check over here the overcast? 1, 2, 3, 4. We have to check the present class. Present class is 1, 2, then 3, 4. So all the classes are present in present class. So probability of overcast given P is 4 by 9. There is a no instance in the not present class. So the probability of overcast given N is 0 because there is a no instance in that category. So in the similar way we have to calculate the probability for the temperatures with respect to the present class and the not present class, then humidity and windy. So this is the similar version, simplified version of the previous table. This table contained all the input features with the probability for the both classes, present and not present class. Suppose if we are taking the unseen sample, the sample is X, we can see the input features are rain, hot, high and false. As we know, the data sets contain input feature is outlook, temperatures, humidity, windy. Right, so here when outlook is rainy, temperature is hot, then what is the third feature? I think it's a windy. Sorry, it's a third feature is a humidity. So humidity is high and the last feature is a windy. Windy is false. We are going to predict the output classes. For finding the output class, I already explained we have to find the frequency table. Then the second step we have to find the likelihood probability for the each attribute. Then finally we have to apply the Navier-Bayes equations to calculate the posterior probability for the both classes. In our example, we are having the two classes which are play and not play. So this formula I have taken from the Bayes theorem. The first part indicate the posterior probability for the present class and the second part is the posterior probability for the not present class. So what are the input here? X is a rain, hot, high and false. So the formula is rewritten as probability of rain because that's the first attribute. So probability of rain given B multiplied by probability of hot given B, then probability of high given B, probability of false given B multiplied by probability of P, which means the probability of S class. So in the previous table I have take the outlook is rain, right? Then the temperature is hot and the humidity is high, then windy is false. So we have to take all the probability value from the frequency table. I am substituting all the value here. I can get the probability value of 0.010582. So likewise we have to compute the posterior probability for the second class, which means the not played class. So the value is I am getting 0.018286. So what the Navier-Bayes algorithm do? Finally it will pick the highest probability of the class by meaning of the augments. So here the second class having the highest probability. So the sample X is classified into the second class. So this is how we can calculate for any real-time applications based on the Bayes theorem, but it mainly used for the classification task. So let's see the type of the Navier-Bayes algorithm, which are Gaussian Navier-Bayes, multinomial and Bernoulli Navier-Bayes algorithms. So when the input are in a Gaussian distributions, it means it follow the bell curve, we can use the Navy-Bayes algorithm. When the multi-Navy-Bayes algorithm is commonly applied for the document classification using word frequency, I already explained in the first part. When you take the news article by using the multinomial Navy-Bayes algorithm, we can classify the news article into the different categories, like whether it's a sports or a technology or the politicals. And then the third one is a Bernoulli Navy-Bayes. It's similar to the multinomial but uses the Boolean predicator indicating the presence or absence of the word in the text. These are the common types of the Navy-Bayes used for the classification task. Then advantages of the Navy-Bayes, it's very easy and fast for the class predictions on the training data, and is effective for classification problem. It supports both multi-class and the binary classification. It outperforms the other models like logistic regressions, but when considering or assuming the each variables are independent to each other, and it requires less training data, work better with the categorical input than the numerical data because it mostly support for the classification problem. So this is a sample gate questions. You can see the Navy-Bayes classifier is used to solve the two-class classification, which means this is the binary classification problem with a class label y1, y2. These are the output label. Suppose the prior probability or the probability of y1 is 1 by 3 and the probability of y2 is 2 by 3. Assuming the discrete feature space with probability x given y1 is 3 by 4 and probability x given y2 is 1 by 4. For the specific feature vector, the probability of misclassifying x's. Here they are asking what is the misclassification probability. So whatever we explained in the mathematical part of the Navy-Bayes algorithm, after applying this we have to find out the posterior probability. We can check the answer is 0.4. So we can practice same way for the gate. We will continue on the next class. Thank you.